Cool. All right, here we go. It is the section 2.7 pre-calculus instructional YouTube video, talking about solving quadratic inequalities, inequalities with rational expressions or rational functions, and also finding the domain of a square root if the argument, the thing under the square root, is quadratic or a rational expression. All right, let's go ahead and basically this video, I'm just going to do 3 examples, talk through them, and that'll be the video. So hopefully it won't take too long. We're going to start off with trying to find the solution set for x squared minus 8x plus 2 is less than 11. Want to find the solution set and then sketch or graph the solution set on a number line. So first thing we're going to do, because it's a quadratic, it's easier if we set one side equal to 0. So I'm going to take this 11 and I'm going to subtract it on both sides. So I just go minus 11, minus 11. That gives me, oh my goodness, what am I doing? That gives me, let's try this again. That gives me x squared minus 8x minus 9 is less than 0. So now what we want to do is find what we call our key numbers. So we know this is, the graph of this is a parabola, right? Something like this. Let me see, well, it doesn't really matter where the y-axis is. But here, right, we're positive, positive, negative. And the only way to go from positive to negative, or y values, is if we go through 0. And the only way to go from negative to positive is through 0. And this is for a quadratic or a polynomial because they're continuous. The only way to get from positive to negative or negative to positive in it with a continuous function is to go through y equals 0. So basically we're going to find our key numbers by finding when this x squared minus 8x minus 9 is equal to 0. So what we're going to do is we're going to factor the x squared minus 8x minus 9. We need 2 numbers that multiply to negative 9 and add to negative 8. So I'm going to go x minus 9 times x plus 1. We're going to see when does that equal 0. So basically just this equals 0 when x minus 9 equals 0. So when x is 9 or when x plus 1 equals 0, x equals negative 1. Okay, those are our 2 key numbers. Those would be like our x-intercepts here, right? So our graph would look like this, right? Negative 1, positive 9. So basically, we have a number line. We got 0, negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, on that number line, this function, this x squared minus 8x minus 9, could be either positive or negative on this interval from negative infinity to negative 1. So basically, over here it could be positive or negative. In between negative 1 and 9, it could be positive or negative. And greater than 9, it could be positive or negative. So what's happening here, basically what's going on, is we identified where the function crosses the x-axis. In other words, when the function is 0. So if we are less than that value, it could either always be positive or always be negative to the left or less than that value. It could never be negative for some of the time and then positive for some of the other time, because it would have to go through 0 again, and it only goes through 0 at these 2 points. So basically by finding the zeros, we're chopping up the number line into these intervals, and then basically we can just test each interval to see if is the function or this expression, is it positive or negative on this interval? Is it positive or negative on this interval? Is it positive or negative on this interval? And we can do that just by checking one number in the interval. So let's go ahead and do that. Even though we already know from the graph where it is, If we had something that was a little more complicated, say a cubic or a 4th degree, 5th degree polynomial, and we had the zeros, we could test it this way. So I could pick a number like -2, because -2 is in this orange area, it's less than -1. So I could say x equals -2, I could say x equals 0, that's in between -1 and 0, and I could pick x equals 10. And we can use either form, the standard form or the factored form, to check for positive or negative. Because remember, we want to know when it is less than 0, when it's negative. So here I can put a -2 in, so if x equals -2, I'm just going to use the factored form here, -2 minus 9 times -2 plus 1. That gives me -11 times -1, which is positive 11. It's positive here. So we don't want that interval. Now if I pick 0, I'm going to use this for 0. So 0 squared minus 0 minus 9, that's negative. I don't even have to really write that out. Or I could just go -9 times 1 is -9. So if x is 0, that's what we get. So we're negative here between -1 and 9. And then if I pick a number greater than 9, so in this interval, like x equals 10, I can have, let's use this, right? We can use either one works. We're going to get 11. We'd have 100, so 10 squared minus 80, which is, right, 10 times 8. And then minus 9, so 100 minus 89, positive 11, so we're positive here. We want when this is less than 0, so it's this interval. So the solution set is from -1 to 9, and then the graph of the solution set would be we'd go like this. And let me get a color like green. So we're not including -1 or 9 because it's a strict inequality. We just want when it's less than 0. So we're going to do a parenthesis at the -1. We're going to do a parenthesis at the positive 9. And we're going to shade in between those values. So this is the graph of the solution set. This is a solution set written in interval notation. If, for example, it was going the other way, if it was greater than, then, so if I wanted to know when x squared minus 8x minus 9 is greater than 0, or in other words, when this is greater than 11, it would just be the opposite. We would have the intervals from -infinity to -1, union with, let me move this out of the way in case you can't see past the chair, union with 9 to infinity. Basically, it would be this part of the graph. So notice, from -1 to -infinity, 9 to infinity, our parabola is above the y-axis, and between -1 and 9, it's below the x-axis. So here it's positive, here it's negative. Right, remember that's what it means. Less than 0 is negative, greater than 0 is positive. And that first step, don't forget that first step, right? Try to make one side equal 0. All right. And also, right, make sure you're using these parentheses instead of open circles. If it's or equal to, we use a bracket. So we're going to do another example here. So I'm going to erase this. Get that chair out of the way. There we go. Here we go. So that is a quadratic. I'm going to do a rational example next. Let's say we have 4x minus 1 over x minus 6 is greater than or equal to 3. We want to find the solution set. For that, I'm going to sketch a graph of the solution set. And that's rational now. So, go ahead and try this since you already sat through class and we did an example similar to this. Go ahead and give it a shot. And so pause the video, try it, and see how you did. All right, so with this, it's a rational function, or this is a rational expression, right? F of x equals that would be a rational function. So there's an extra thing we got to think about for our key numbers. In general, we still want it to equal 0, so we're not there yet. But our key numbers can happen either at x-intercepts, just like with the quadratic, but also we can have vertical asymptotes here. And on a graph, right, if I have a vertical asymptote, I could have something like this, where it's negative on the left of the vertical asymptote and it's positive on the right-hand side of the vertical asymptote. So the function, or the expression, can change from having positive or negative outputs, either when it crosses through y equals 0, right, an x-intercept or a 0, or when the x values cross from one side to the other side of a vertical asymptote. So, just keep that in mind. First step here, just like before, we want to make it equal 0, so I'm going to go minus 3, so I get 4x minus 1 over x minus 6 minus 3 is greater than or equal to 0. Now this is like, no thanks. What we're going to do, we want to make it so that we have one rational expression. So what we do is we got to combine, oh my goodness, I almost said combine like terms. We need a common denominator. This denominator is 1, this denominator is x minus 6, which means we need to multiply by x minus 6 over x minus 6. So that gives me 4x minus 1 minus 3 times x minus 6 divided by x minus 6. Notice I didn't multiply both of these by 3, right? I kept it minus 3 parentheses, so I don't forget to distribute the negative part with that 3. So it's greater than or equal to 0. I'm going to distribute that negative 3 now. So that's going to give me negative 3x plus 18. Negative 3x, positive 18. So 4x minus 3x is x. Negative 1 plus 18 is 17. Well, that's a fun number. And then x minus 6 is greater than or equal to 0. Okie dokie. So we've got x plus 17 over x minus 6 is greater than or equal to 0. We want to find our key numbers. The way to find our key numbers, remember, because it is a rational expression, the key numbers here are the x-intercepts, or the zeros, and the vertical asymptotes. So we're going to have an x-intercept when the numerator is 0. So x plus 17 equals 0 when x equals negative 17. That's one key number. Boop. The vertical asymptote is going to happen when the denominator equals 0. So x minus 6 equals 0. X equals 6. So that's a vertical asymptote. This is an x-intercept. All right. It gets a little tricky though. So stay with me. So basically, we've got 6, we got negative 17. Good. Yeah. Let me draw out this number line here. We have 0, negative 17, and 6. So we know right here at 6, we have a vertical asymptote, and at 17, right, y equals 0. Now what we need to do is we need to find out, is it positive or negative on the left of negative 17? Is it positive or negative on the right of negative 17, but less than 6? And is it positive or negative when we go to the right of 6, or when we're larger than 6? So we've broken it up into negative infinity to negative 17. I'm going to put a bracket on the negative 17 though. The reason I'm putting a bracket is because I have greater than or equal to 0 that I'm trying to find, right? So it's greater than or equal to 3. The bracket means equal to. When x is 17, when x is negative 17, this equals 0, this equals 3. Right? Yeah. So, negative 17 is going to be included. And then here I get negative 17 to 6. I'm going to put a parenthesis on the 6 though. The reason I'm putting a parenthesis on the 6 is because the 6 represents a vertical asymptote, which means the output is undefined when x equals 6. So that's the difference between the bracket on the negative 17 and the parenthesis on the 6. And then here once again, let me do a different color, parenthesis on the 6, still purple, 6 to infinity. So we've split this number line into 3 segments or 3 intervals again, and we're just going to check positive or negative inside each interval. These are the only places where it can change from positive to negative, right? Here or here. So we got these 3 spaces. So let's try like negative 18. So here, I go orange, x equals negative 18. Woo, positive or negative. So I go to this, we've got negative 18 plus 17 over negative 18 minus 6. Well, that's going to give me a negative 1 on top and a negative 24 on the denominator. So here, negative divided by negative is positive. Should have used orange there, but here we are positive. So this is one of our intervals we want. Yeah, we're like, all right, woohoo, positive. Yeah. Now let's check on the other side. So in between, so let's just check like 0. 0 is a nice, easy number. All right, let's go green for this. So in here, x equals 0 is between negative 17 and 6. So I get 17 over negative 6, because 0 plus 17, 0 minus 6. That's negative. This is not what we want. We don't want this one. We want it to be greater than or equal to 0. And now here we're going to see, does it change sign or not when it goes to the other side of the asymptote. So here let's pick like x equals 7. So I get 7 plus 17 over 7 minus 6. That gives me 24 over 1, which is positive. Woo! But don't need a 1 there, it's just positive. So we have this. So our solution set is negative infinity to negative 17 bracket. We're including the negative 17 because that is a 0 and 1 when it's equal to 0, because we want it when it was or equal to 3. And then we union that with that U symbol with 6 to infinity, where we don't include the 6 because the 6 gives us a vertical asymptote, so the function is undefined when x equals 6. But when x is larger than 6, we have a positive. Or this would be greater than 3. Okie doke. Yeah, that's it. Oh, we want to graph it as well. So to graph it, we would just go like this. 0, negative 17, 6, right? Put in the dash marks appropriately. And then we would put a bracket on the negative 17 and an arrow going to the left to say we get negative infinity to negative 17. We get all those to the left. We would put a parenthesis on the 6. And we get everything to the right. Right, 6 to infinity. So that would be the graph of the solution set. Okay, and remember, we're using brackets and parentheses instead of open and closed circles because it's pre-calc and that's the way the textbook does it. And on WebAssign, on the assignment, right, it's computer-based, so it might not give you points if you use the circles. I'm not sure. All right, we got one more problem, and that'll be it. So let's do one more. So let's say we have the square root, so f of x equals the square root of x minus 1 divided by x squared minus 3x minus 18. I want you to find the domain of f of x and write it in interval notation. Okay, go ahead and try that. Let's think about it. Or let's think, like, what would be a good first step there? What should we be doing? Well, if you're thinking about it, you might remember, domain. Well, if it's a square root we need whatever's inside the square root to be greater than or equal to 0. And we've got a fraction here, so it can't equal 0 in the denominator. So here, right, x squared minus 3x minus 18 cannot equal 0. Right, and x minus 1 over x squared minus 3x minus 18 has to be greater than or equal to 0. So basically we can solve this. We're going to get these values when we find our key numbers, right? Because remember, the vertical asymptotes are key numbers here. And we'll just have to remember that those are vertical asymptotes, so we kick those values out with a soft parenthesis, not a hard bracket. All right, so key numbers. Let's find those key numbers. So key numbers are the x-intercepts. That's when the numerator is equal to 0. So that's where x equals 1. That's one of our key numbers. And then when the denominator equals 0, x squared minus 3x minus 18 equals 0. Right, that is x minus 6 times x plus 3 if we factor it equals 0. Right, that multiplies to negative 18, they add a negative 3. Right, because there's a 1 here, it's just 1x squared. So x equals 6 is a key number, x equals negative 3 is a key number. So x equals 1. Now I'll put these in orange to remind myself that they represent vertical asymptotes. X equals 6, x equals negative 3. So we're going to cut up our number line into segments, into intervals. So we've got 0, 1, negative 3, 2, 3, 4, 5, 6. And now we have 4 intervals. We have an interval from negative 3, or negative infinity to negative 3. We have an interval from negative 3 to 1. We have an interval from 1 to 6. And from 6 to infinity. Right? And we can make brackets on the 1, but need parentheses on the 6 and the negative 3. I'm holding off on the brackets though, because it depends on which side that I want to be on. Right? I mean, we can put a bracket there if we want to. That's fine. Okay. Doesn't really matter. So basically what we need to do is we need to check a point in each interval to see where it's positive, where it's negative. Right? Because the only way that it could change sign, go from positive to negative or negative to positive, is when x jumps from one of these intervals to the other one. So I just need to pick a point, an x number, like x equals negative 4. X equals 0, because that's between negative 3 and 1. How about x equals 2? And then x equals 7. Or let's go with x equals 10. Let's just pick a nice easy number to work with. 10's easy. Alright, so x equals negative 4 here. If I put that into x minus 1 over, well, I'll just put it into that function, so I get negative 4 minus 1. I get negative on the top, and I'm going to get negative 4 squared is 16. Minus 3 times negative 4 is going to be a plus 12. And then minus 18, because it's minus 3 and a negative 4 makes it a positive. Right, this gives me 28 minus 18, so it's negative 5 over 10, which is negative 1/2. We are negative here. So we kick out this. Not that one, because we want when it's greater than or equal to 0. So now let's check x equals 0. If I put 0 in here, boom, we can just cover up all the x's. Negative 1 over negative 18 is a positive 1/18. So we are positive here. I don't know why I keep running to put a 1 after it, but it's positive. Yeah! Woohoo! Positive. So our solution set includes this interval from negative 3 to positive 1. We're including the 1 because the 1 is an x-intercept. We are excluding the negative 3 because that makes the denominator equal 0 and the denominator cannot equal 0. All right, let's see. Maybe there's going to be some other ones. I'm going to throw that union in there just to see. All right, even though it's a U, we're going to see. It's like a C that took a nap or a U that got up. Right, because this is a C and this is a U, right? They're just rotations of each other. Okie doke. That was fun. So x equals 2, let's try that. If I put 2 in for x, I get 2 minus 1 over 2 squared is 4, minus 6 minus 18. So basically it's 1 over negative 20. We're negative here. Negative, we don't want that one. All right, let's just check this last one. Let's check 10. So x equals 10. We get 10 minus 1 over 100 minus 30 minus 18. We get positive over positive, right? Whatever number that is, 9 over 52, right? But it's positive. So we also get this interval, 6 to infinity. So the domain of this function is all the x numbers between negative 3 and 1, including 1, and then greater than 6, right? We don't have the bracket on the 6 because 6 makes the denominator equal 0. So the domain here is negative 3 comma 1 union with 6 to infinity, right? Basically, it's just whenever this is greater than or equal to 0, right? And that's it. Hopefully this made sense. Hopefully these examples were helpful. If not, you've always got office hours, so you can ask questions there. So have a wonderful day. Thanks for watching, and go Bulldogs!